have to keep doing it. So, what I want to do today, like I said, is talk a little bit about what something's called Kramer. Hey! I know you're going to be here.
Yeah, I just ended, so I was like, might as well come to math.
I'm sorry you had to go to that. No, but I'm really sorry.
Okay.
We're happy to see you.
Yes.
Woo!
Her name is Val.
That's Val!
It's Val.
You!
Actually, you're wrong. It's Vic.
It's Vic, that's right, it's Vic. So,
Wait, don't confuse me. I'm not good at this.
what I want to do is show you the reason why determinants are useful. They are useful because of this little thing called Kramer's rule. Kramer's rule is a method to solve systems of equations. It may not be the most efficient way to solve a system that's, two equations, two variables, but it is a very easy way. When you're talking about systems of equations, you're talking about two equations, two variables. Normally you would have it where you'd have to use substitution, elimination, or one of those methods. What this does, it allows you to use determinants 3 times, really, with a 2 by 2 matrix. And we know 2 by 2 matrices with determinants are of 3's. So, here's what you do. I want you to write down this matrix, or this system, and we're going to turn it into a matrix. We're going to take this system of equations, 2x plus y is 1, and 3x minus 2y is negative 23. And I want to take that system of equations, and I'm going to create what's called a coefficient matrix. The coefficient matrix is going to be the coefficients of the x and y. I'm going to keep the x's in the same column and the y's in the column. So the coefficient matrix would be 2, 1, 3, negative 2. Everybody all right with that? Just plucking the coefficients out. Hence, coefficient matrix. All right. Find the determinant of it right away. We're going to find the determinant of this coefficient matrix. Remember, chutes, then ladders. Work your way down to work your way up. All right. Negative 4 minus 3, you get negative 7. So the determinant of the coefficient matrix is negative 7. You okay with that?
Yes.
All right. Now here's where we use this. Do you guys agree that I have 2 possible solutions?
Yes.
What I'm going to do is I'm going to take that solution, and you see how it's lined up like a column?
Yes.
I'm going to take that and I'm going to solve for x, and in order to do that, x is going to equal, well, in my original matrix, I had it as 2, 1, 3, negative 2. I'm going to take these values, the 1 and negative 23, and replace them in the x column, and keep the y column. Because I'm solving for x, I'm going to put the answers in the x column. Find the determinant. Chutes, then ladders. Negative 2 minus a negative 23. You get positive 21. You okay with that? Divided by the negative 7 is fine. Yep. 21 divided by negative 7 is? There's x.
Do we do the same thing? We just substitute x.
Do you do the same thing? Well, I'm going to have you guys do it the same way. I'm going to have you use determinants each time. I know what you mean. You can substitute and be done. What I'm going to do now is use the same method to solve for y. I'm going to take that solution column, the 1 and negative 23, and I'm going to put it in for the y column in the original matrix.
Did I receive the 2 or 3 or the 1 and negative 1?
The 1 and negative 23. That's the solution. It's the equals part. So what I'm going to do is go back to the original 2 and 3, because the y value is going to equal the determinant of the 2 and 3. In the y column, I'm going to put the solutions of 1 and negative 23. I'm going to find that determinant, and then divide it again by the original coefficient determinant. So you're basically using determinant 3 times. And with a 2x2, 2x2 determinants are a cakewalk. Well, shoots, then ladders, negative 46 minus 3 is what?
Negative 49.
And negative 49 divided by negative 7 is?
7.
There's your solution, negative 3 and 7.
Oh, what's the negative 7?
It is a,
That's long.
and yes, Emma, it does take a little bit more time for a 2x2, but remember the pain in the butt it is when you have to use a 3x3 or a 4x4. It's a horrible, horrible, horrible setup. Of course. But determinants are easy. Because it's so much easier just to multiply and add and subtract than it is to try and do all the substitution methods or the row swaps where you had to eliminate the values and resubstitute back in. That's a pain. Determinants, shoots and ladders. Okay? Does that make a... What's that? Well, I'm thinking of the fact of the game shoots and ladders. That's all I'm saying. I'll show you all. Same idea. And I'm showing you guys these with the 2x2s to start with because, yeah, 2x2s are relatively simple to calculate in your head. And and Olivia, once you see this with a 3x3, you're like, oh. And if you do it a couple times, it is relatively simple because all you're doing is multiplying it. So, I'm going to go ahead and find the determinant of what we call the coefficient matrix. The coefficients are just the numbers in front of the variables. What happens if there isn't a variable? What happens if it's just 8x equals 2? What would the y variable be? 0. Yeah. You won't see that very often with 2x2s, but you will see it pretty often with 3x3s or 4x4s. So we get the determinant of the coefficient, which is 8, 5, 2, negative 4. I wasn't even spinning it, I just dropped it. Shoots, then ladders, negative 32 minus 10. There's your determinant. Take your solutions, the 2 and negative 10. When I solve for x, where do I put those? In the x column. Very good. And what am I going to have to divide this by when I find that determinant?
Negative 42.
That's all it is.
Will the numbers always be lined up like x then y?
Yeah, you should have it set up that way. Just put it, as long as you put it in the column correctly, you'll be fine. So you have negative 8 minus negative 50.
Is 42? Negative 1.
You get negative 1.
Negative 8 minus negative 50.
Shoots, negative 8 minus negative 50. When I do the y, I have the 8 and 2, negative 10. Shoots, ladders, negative 80 minus 4, negative 84 over negative 42 is?
Is there anything special when you have like an 8 and 2 and a 2 and 8? Because it's like,
There's nothing special.
it just seems like something.
You're searching for patterns because that's how you think.
Yeah. Or like you have 4 2s and it's just 0.
Right. We'll try a 3x3.
I don't think.
What's that?
Might as well.
We got the time. I got the
I guess.
should be using our
Like
periscope.
35 minutes.
What's that?
That's a telescope.
Yeah.
Sure. Yeah, there's one, right?
Periscope number was on
This is
the
long, the hair, the hair.
Okay. Same idea. You do the exact same method. We're going to start with the idea of the coefficient matrix. With it being a 3x3, it usually takes an extra minute to find the determinant. But then when you solve for x, you take that solution column for x. When you solve for y, you put the solution column in for y. When you solve for z, you put the solution column in for z.
We have to do 3 different determinants.
It's actually 4 determinants total you're doing. That's, what's that?
Shut up, Then you go and beat each other.
That's gravity.
Holy. Mojo up.
Please.
Mojo up.
Mojo up, Thomas.
That's right. He went to middle school. I was like,
That's all I have to tell you is mojo up. Lily wouldn't hurt a flea.
Why'd you duck her feeling?
not fleeing.
Oh.
Nothing more than feelings.
Okay, let the ass stop.
Color coded. I don't know. Just making up stuff.
Do we have to add?
Is it June 10th yet?
Do we have to add like?
Did you know, it's like, so when we back at certain finals next day, you have to add.
No, because that's, we only have to do that when you define the area of traffic. Here you're gonna have.
I thought that was when you were going for my house.
God, that's the area of traffic, yeah.
But I'm talking about like, do we have to do the thing where we have? Like when you're solving it, having your 2 extra columns to find the determinant.
Oh, you can if you want, yeah.
Okay, wait.
Oh, I know, now I know what you're talking about. I'm sorry, I thought you were asking, I thought you were talking about something else. I'm trying to avoid Olivia as much as possible.
Did I dream up this lesson?
That's fine.
Are we?
I should have it done by the weekend. So we can get to the determinant.
This is actually a lot of times
Watch your signs. Watch your signs. You need to have your signs correct. It's not going to work. It'll be wrong. So we have 4 plus 6 minus 12. So that gives me -6, negative 2. Ladders gives me 9, 4, and -8. So that's -4 and 1. So I have -2 minus 1, which is -3. Is that right? Everybody agree, disagree?
What? That's not what I read.
Oh, I meant 9. I wrote, why did I write 4? I'm sorry. Sorry.
I got -7. I got
9.
No, you're right, it is 4.
I got 3. I got
Bless you.
Mr. Murphy, I'm not kidding.
I got -13.
Oh my God. It's negative.
Guys, just everybody stop. Okay, hold on. Shoots. 4 plus 2 times 1 times 3. 6. -3 times 4. That's -2.
Yes.
Ladders. 9. 4, 1, and 1. 4. -4, 1, and 2. Minus 8. -2 minus, this is 5. So it's -7.
Nailed it.
Okay?
For the bottom one where you're going up, I got negative times -1 times -3. That's negative.
No, it's 3
Oh.
times -1 times -3.
Oh.
Wait.
So your determinant is -7.
This is probably the hardest part.
Okay? Shoots, then ladders. Now your x value is going to equal solution column, y column, z column.
Is it supposed to Y column is the same as the answer column?
It's not.
It's, oh, nuts, I did this wrong.
Okay. Determinant. Shoots, then ladders. -8. What's wrong? +8. -3, -1, and 4. The shoots give me 12. The ladders are going to give me, well, 12, 4, -8, -4, and +8. So it's going to be 12 minus 12. So what's my determinant?
0.
So it's no addition.
No, 0 percent is 0. It's divided by 0.
But you can't multiply by 0.
No, wait, I screwed something up there.
No, I got
I'm
the same
No, I
answer.
got-
Why do I screw it up when I get to you guys and
I got
all
the
throughout
same
the day, everything
answer.
else worked fine?
I mean, I got the same
That's
answer.
correct.
But you're right.
I got 0.
Yeah,
I got zero.
Dylan and I got the 7 right, and
I
we got the
got
same
it.
You're
answer.
not supposed to be getting, not supposed to be getting. Oh yeah, you are getting 0. Duh, I'm thinking because you're dividing, it's 0 divided by -7, so x is 0.
Hey, Dylan.
It's okay. For some reason, I thought that was the coefficient matrix.
Does that mean
Duh.
at this point, like, it's crossing, it's a 0, like, x is a 0?
It means,
Like, it's touching the origin of
What's
the graph?
happening here is that the 3 lines will intersect at the coordinate of x equals 0 and 2 other coordinates. And when you graph in the 3-dimensional plane, it looks completely different.
Oh yeah, I saw a sine graph, 3-dimensional. It's like,
It's crazy.
It comes upward like a volcano.
Yeah.
It's cool.
Y column.
So you come up with
It's 1, 1, 3 for the x. I need to put the solution column in next. So that's -2, -1, and 4. The z column is -3, 1, -4. I have to divide all that again by -7 and move this up some. Shoots, 4, -6, -12. You get -14. Ladders. 3, -1, -3 gives you 9. 4, 1, and 1 is 4. -4, 2, -2 is 8. So that gets you 21. So it's -14 minus 21. So you get the y value is going to be -35 over -7, which is 5. So now you've got ordered pairs at 0, 5, and then move the solution column to the z values. Two negative. So our solution column of -2, -1, and 4 slides over to the z column for the last one. And we'll find its determinant again. Shoots, then ladders. Slide this up bigger. Shoots, -4. The -6, and -8. So -18 on the shoots.
I don't know, I'm still on Y.
yeah. So like, I'm just gonna watch you do it. It's course, yeah.
I will say use Kramer's rule to solve all consistency, yes, you have to use the Kramer's rule. As I say so. Ladders. 6, -4, and 8. So it's minus, so this would be 10, so it's -18 minus 10, which is -28. So Z is -28 over -7, otherwise known as?
So that means there's on a big like cube, there's 3 lines going through and they all intersect at 0, 5, and 4.
What happens then, if you want to think about it in terms of how that looks,
So isn't the 6 negative?
your X, Y, and Z, okay? Your X values, how does this work? Are here. Your Y values are here. And your Z values are here. So you're at 4 at the Z, 5 at the Y, and 0. So you're at 0, 5, and then it's 4. So it's like floating in space. It's not something we do a lot of with Z. Or actually, I'm sorry, it goes back. I forget. I think Z goes backwards, yeah. So, whatever. It's a weird, there's multiple ways to graph 3 dimensions. It's not something you see very often at all.
We don't learn it.
I don't think so. I don't think it even bothers
We
to
learn
bring
it
it up.
in high school at all.
We used to teach a little bit of it. There was some of it in chapter 3. But it's not something you do a lot of. You really don't, because there's no real practical application of it.
Okay.
Unless you get an engineering, then you do CAD drawing, and it's not, then it's just doing it on the computer.
I know.
Let me give you one of these to try on your own.
Well, that's why I don't know how to do Jewish
Pretty good, right?
Try that again.
Is it back?
Yeah, 12 or 12. Not 29, 39.
Oh, I'm over there. Oh, yeah, there's 39, so that gets you.
And
And
then
then that one's
that gives you
47.
47. The bottom.
Well, that's the, yeah, the bottom one is 47.
Oh, I screwed that up, that's good.
Yeah.
So,
You still got the
You
right.
got the right answer, it's the wrong number.
so it's 49.
Oh, it's 37 minus,
You know what else? We can jump in the car. We can do
39
like
minus
once a week
47.
TV show. TV show with Scott Bakula. Dude,
So that's gonna be what?
dude.
Positive.
-8, yeah.
I love those. Makes me feel so special.
All right. So X we get 2. Do it again for Y. Y's we have 1, -2, 3. Solutions, 1, -3, 4, -1, 1, -2. Down 6, 1, 3, -1, -2, 4 is 8, so 9 and 8 is 17. Upward is 9, 4, 4, so 17. Woo-hoo, Y is 0. And then Z,
17 minus 17.
and then Z
Just watch you do it like she says, great. You should like use off and just like.
Negative 4.
She's like, what I'm trying to do.
Negative 24.
Stop. I'll tell you right there.
She's like
7.
mini legs inside her head.
That is negative 61.
Just making sure we got there. Yes, negative 61. Upwards, you have negative 18. Negative 15. And negative 4.
Negative 4 divided by negative 4.
So yeah, negative 4.
Yes,
System.
see, I went slow and steady. And
Yeah, remember, the worst thing that's going to happen is you forget to write down a sign, you forget how to add. But the process to doing these, it's still a lot faster than trying to solve the entire system. When you do the system, it's a pain. Okay? Let me give you 5.
Are they the same problems that Hannah wrote up there?
Yeah.
Okay, I was gonna write some.
I was working on my other brother.
Wait.
The brother had the pencil out.
Hannah was
I was just being annoying.
The lead broke.
She was texting me.
But now whenever I look at it, I just go, they look like I got black cats.
Are they all going to be
That's mixed. So this is still 4.3. It's page, what is it, 219? She wrote down numbers 40, 41, and then 48 to 50.
Oh, I do, or else I forget.
Give me a second and I'll come up.
No matter what. So I do, but yeah, I do my homework.
I wake up every day at 5 o'clock in the morning.
Wait. It's already Thursday.
Here you go. Have the I forgot to pack it that day.
It's so crazy to see you
There you go. You got those 5. Please and thank you.
You're welcome.
Oh, when you do the triangle one, I'll be stopped.
Like, what the turtle would have won if the hair was just like, laughing. Think about it.